Hello, anyone! Thank you all for coming to this show. We are really excited about it, me and my fiance, who's here with me.
Hi, I'm Becca.
And since you're here, you're probably excited about it too. Or there was just nothing better on TV, which is fine too. Because by the end of the show, you'll be glad that there was nothing better on TV. At least that's our goal.
You know, the thing is, when you're watching TV, you can always just, like, watch reruns on Netflix whenever, but solar and lunar eclipses, they don't come on demand. So if you want to see them, you'll need to know when they're happening and what to look for. And even if it's, it's even cooler if you can make sense of what you're seeing by understanding what's going on out in space.
Well, for most people, or most of the time, you'll need to know when it's happening to make sure that you do see it. For a few people, for total eclipses, they could just be out and about, and then suddenly broad daylight turns to darkness, or the moon suddenly turns blood red.
With those people, if you don't know what's happening, then they just start hoarding peanut butter and building underground bunkers and preparing for the apocalypse. So we want to avoid that.
Before we start, though, I want to encourage everyone to ask questions. If something isn't making sense, or something I say makes you wonder about this or that, don't hesitate. Just throw it in chat. This is like the whole thing about this show.
Yeah, and it's not just lip service. Like, we really want you to ask questions. We've been doing these shows for a little less than a year, these online shows. And I think that's one aspect that we haven't emphasized enough. When I was in school, I always felt like asking questions was stigmatized. Like, I felt like I should already know the answer, or I'd be judged in some way. And from my perspective, in addition to science outreach, my main goal with Fly Science is to help people not feel that way. Because if someone is judged for asking questions, the implication is that there's something wrong with them, that like they're not accepted for who they are, or who they are isn't enough, not meeting expectations. And golly, if the stakes are that high, then yeah, it makes sense that people would be like hesitant to speak up. So the stakes should never be that high, and the stakes are definitely not that high here. So help us set that precedent. Just ask your questions. And if we don't know the answers right away, right off the bat, then we'll do some research and add it in the supplementary info that you can check out after the show, or I'll actually share the link to that right now. We have some of it up already, so you can look it up right now, right after the show, to like go over some of the things we talk about in the show. And then if there's like extra questions, we'll just add that in later and let you know when that happens. And, you know, you can also go back and rewatch this anytime. That'll be up in the supplementary info. And, you know, that way you can share it with your friends, your family, everyone that you know, so that we get more followers.
But before we start the show, I want to start off with some acknowledgments. If you've watched our previous shows, in addition to this one, you may notice that the graphics of this show will have dramatically improved in quality. We have two friends to thank for that, Rachel Dressler and Trevor Castle. Rachel is an amazing artist, talented, skilled, creative. I'm always in awe at the air quote doodles, as she would call them. She just whip up in like a half an hour when she's bored. Doodles I'd expect to see for sale for hundreds of dollars at a hipster coffee shop or art gallery in a renovated warehouse hidden in the heart of a big city. One time after she sent me some pictures of her artwork, I had this idea that her art could elevate these shows to a whole new level from the kind of freehand clip art that I was doing before.
Yeah, we always have made jokes in the past shows, like art lessons from James.
So I asked her if she would do the art for Fly Science, and she agreed. And not only did she draw some of the art in the show, these are all hand-drawn artworks. The moon, earth, and sun are, at any rate. But the paper that she drew it on is she made as well. It's made out of recycled cardboard egg cartons. So we'll have in the supplementary info, we'll have a link to a video that she made about how she made that paper. And I encourage you to go over and show some love to her, because she's did a great job, and hopefully she'll keep doing art for future shows as well. But also, Trevor, this show, most of our shows in the past were all 2D. This show is the first of my shows that have three-dimensional animations. And Trevor helped out a lot in terms of troubleshooting and helping me learn how to do some of these animations. And there was even a time where I couldn't get something to work, and he was up for hours after I had already gone to bed to fix it. He's been helpful, patient, understanding. He's an invaluable resource to the team now. Without Trevor, these animations would have been lower quality, and a lot more work for me to have done, including inducing a headache in me. And just to brag on his behalf, since he's, he doesn't necessarily see this as a boon. His coding and programming knowledge, and his knowledge in Blender, which is where most of these graphics have been made, they're all self-learned. His approach to continuing learning is truly inspirational, and what we strive to encourage for at Fly Science.
I hope he's blushing right now. I know he's watching.
But with that said, without any further ado, let's get into it. So there is a lunar eclipse happening on May 26th and a solar eclipse happening on June 10th. Now, what are eclipses? Well, whenever you have the sun, earth, moon in a way that the earth is in between the sun and the moon, so the moon is darkened out by the earth's shadow, you have a lunar eclipse. And similarly, when you have the sun, earth, moon system in such a way that the moon is in between the sun and the earth, and the moon is casting a shadow on the earth, that is a solar eclipse. Now, what exactly would these different eclipses look like from Earth? We'll talk about why they happen and some different aspects about them. But what do they look like from Earth? Because that's what you want to know.
Yeah, that's the fun part.
That's what you're excited about. So a lunar eclipse from Earth, whenever if you're out at the night of a lunar eclipse, for most of the night, for whomever can see the moon, it'll just kind of look like any other night. But eventually, though, because the moon is constantly orbiting the Earth, the moon is getting closer and closer to the outer shadow that the Earth is casting, called the penumbral shadow. And eventually, if you're being extra astute, you'll notice the moon getting ever so slightly dimmer. Then you'll start to see the moon going through what looks like its monthly phases. So the moon's glow, which is caused by the sun's light reflected off the moon, will begin to disappear as it moves into the Earth's umbral shadow. It will get to a point where there's so little light reflected from the sun anymore that the darker parts of the moon will appear to turn more red. When the moon is completely engulfed by the Earth's umbral shadow, there's no more light reflecting off the moon. The entire moon will appear orangish red. And I'll get back to talking about why the moon appears red in just a moment. But as the moon continues through the Earth's shadow, the redness will start to fade as more and more of the sun's light hits the moon once again, as the moon is leaving the Earth's shadow, and eventually the moon will also leave the Earth's penumbral shadow, concluding the lunar eclipse. Now, the most exciting part about the lunar eclipse, moving into the penumbral shadow, turning red, and leaving, that's only going to take about 14 minutes, but the entire eclipse as a whole is going to be like 5 hours.
So you keep saying umbral and penumbral, so what's the difference there?
Well, umbra is Latin for shade, but shadows have different areas to them. The umbra is the fully shaded inner part of the shadow, and pen as a prefix means almost. So penumbra, besides being one of the first horror games I ever played,
Yeah, grab it with your bare hands. Okay.
means almost shadow, and that refers to the lighter outer part of the shadow. Now, let's first talk about why the Earth and the Moon have two different shadows. And the quick and dirty of it is that size matters. The light in our solar system is thanks to our big old sun. And the Earth and the Moon, in comparison, are very, very small. There's nothing in our solar system that gets close to the size of our sun, and this is not to-scale comparison. So light's coming in from all different angles of the sun, but the light that ends up going to the moon comes in straight ahead, up above, and down below. So the light that comes from up above is casting a shadow in the same trajectory that it's going. It hits the moon, and the moon casts the shadow because it's opaque or solid to the visible light. Light's coming up from the bottom, hitting the moon, casting a shadow upward. Now, there's still light coming in from this direction as well, so light is being bled in to the shadows that the light from above and below are making. So it is, it's lighter in there's more light in that shadow, so it's less of a shadow. It's almost a shadow. It's a penumbra. But there are areas where the light just can't get to because the moon is in the way, and that is the umbra, the darker part of the shadow. But as the shadow goes outward, more and more light is introduced to it, so it kind of makes this conal shape, or in 2 dimensions, a triangle shape that eventually disappears. But the moon is at the right distance where it still casts its umbral shadow, and this is the darkest area in a solar eclipse, and I'll talk more about that in a second. Now, as to why the moon appears red in its total phase, is because the Earth has an atmosphere, fortunately for us, and that atmosphere is I breathe the stuff. That atmosphere filters a lot of the sun's light. It's really good at scattering blue light, violet light, green light. And so that's why our sky is blue. But as the sun is setting, that light has to come through more of the atmosphere. So at sunset, you notice that the sky is more red. That's because it's traveled further through our atmosphere, and what reaches us is more of the red light, because red light doesn't really get affected by our atmosphere as much. So the reason that the moon turns red is because there is light that is like skimming the Earth. It's going through the atmosphere and narrowing in, and that red light, the blue light, gets filtered out. Any other light besides warmer colors like red and orange and yellow, they make it through. And so that kind of permeates or gets mixed in with the umbra, and which makes us see a red moon. But it's very dim light. So that's why you don't see the red part of a total eclipse until the moon is far enough inside the Earth's shadow that there's less light to drown out the very faint reflected red light. Now, probably one of the second most important things you want to know about is who is going to see this eclipse. Because that's what you want to do. You want to see this eclipse. It's not often we get a total eclipse, and they're not very common. So you want to take advantage of the situation when you got it. Well, if you're watching from the East Coast, I have some bad news for you. You're not gonna see the moon turn red. But if you're from like central US over to the left, you will, get the opportunity to see the moon go into its total eclipse. And so here in the East Coast, we're going to just barely see the moon get into the partial eclipse phase, where it's just kind of darkening some of the moon. You're gonna write a letter of protest to NASA. Tell them, how dare you leave the East Coast out of this, NASA? Why don't
Because
you?
NASA controls these. That's the.
Why don't you, NASA? Why don't you move the moon? Wait, tell the moon to go a little faster, or tell the Earth to spin slower. Over to the West Coast, they are going to see more of a partial starting from as you go more west. But this line here, at about, again, 7-ish Eastern Daylight Time, they're going to start seeing the partial. And as you keep going further over, once you hit this line here over, that's when you start to see the total eclipse. You'll see the moon turn red. And then the farther west you go, the longer you'll see the moon be red. People on the West Coast, they're going to see the entire exciting part of it. They're going to, the people on the West Coast, like in California and Washington, they're going to see the moon entering the umbra, turn red, and leave the umbra. Now, people who are going to see the whole 5 hours of the eclipse, mainly mermaids. They live out in the Pacific Ocean. What's called Africa, Australia. They'll be able to see the entire eclipse. Eastern Russia, they'll be able to see the moon turn red. Eastern parts of China will see the moon turn red just before the moon rises. People in Japan, they'll see almost the entire total eclipse phase, seeing the moon turn red and not. So I'm sorry if you live on the East Coast, but you get payback on the West Coast, and you'll learn why in just a little bit. So what will the solar eclipse look like? Solar eclipse is on June 10th. The lunar eclipse was on May 26th. Solar eclipse is on June 10th. That is even more heavily determined on where you are on the Earth relative to the path of totality. Solar eclipses are harder to see because at the time of the total lunar eclipse, anyone who can see the moon will be able to see the eclipse. But for solar eclipses, only people with the perspective to see the moon in front of the sun can see it. You can see in the animation I have here, that is the moon's shadow trickling across a very specific path on the Earth. Anyone not roughly near the area of the shadow. This shadow is not 100%. I tried my best with the little knowledge I had in Blender to get this shadow to behave like it would in real life. But I'll try. Things will be smoothed out going from here because the show is going to be ever changing now that we have Trevor on staff. Now that we have Rachel on staff, things will improve and they'll get more accurate as we go. But solar eclipses only happen at certain parts of the Earth because the moon and its shadow is smaller than the Earth. It doesn't encompass the whole Earth like a lunar eclipse does. So
Earth shadow encompassing the whole moon for a lunar eclipse, moon shadow not encompassing the whole Earth for a solar eclipse.
Right. So its path of totality, the area where you would have to be in order to see the moon directly in front of the sun, is very narrow. As the solar eclipse unfolds, you'll see the moon getting closer and closer to the sun. And when the moon moves in front of the sun, that is totality for your area. So this is a perspective of if you were in South America during this particular scenario of a solar eclipse. This is not what the solar eclipse that's happening in June 10th is. This is just teaching you what a solar eclipse is. As the moon moves in front of the sun, I'm just going to play the animation again because I ramble. As the moon moves in front of the sun, it gets closer and closer to the sun, and as it moves in front of it, the sky begins to darken, and when it's completely in front of the sun, your sky will be a darker blue. You might see some brighter stars poking through, and your sky will pretty much look like sunset. The moon won't always be in front of the sun for everyone. Depending on where you are on the Earth, you might... I have a second moon here because I wanted to make things easy on myself, but then I didn't categorize things well enough, so I lost it. If you're not directly at totality, you will see just part of the moon covering the sun. And this is going to be a partial solar eclipse. And the less that the moon is covering the sun, the brighter your sky is going to appear. It's not going to look like totality. If this is totality, people right around here, I'm going to point with the moon now because I forgot to put a pointer on this page. If you're here, this is totality for you, but if you start moving southward, you're going to see the moon like this, and if you move further south like this, further south like this, until you get so far south that the moon doesn't even look like it's in front of the sun, and if you live there, you don't even know that the eclipse is happening unless you look it up. Same thing for the north. Further north you go, I had that backwards. South, the moon is above the sun. North, the moon is below the sun. But either way, the result is the same. It's dimmer the further from totality you're at, and you can get so far from totality that you won't see the eclipse at all. And that is what these maps represent. So this is another map from In the Sky, and this is the path. I'm going to point with the moon again because I don't have my on-screen mouse. This is the path of totality that the moon takes. So this is the darkest area of the eclipse, and it comes in on the other side as well. Now that might be confusing. Why does it look like it's going up and around and popping out the other side and down? That's because maps are not a good representation of the Earth as a globe. So I took the map and I spherized it, and this is more accurate to what it's going to look like. So the moon is going to get in between the sun and the Earth, and it's going to cast a shadow. As the moon moves in front of the Earth like this, its shadow treks across the Earth as such. And the moon's penumbra, going back to umbras and penumbras, its penumbra reaches downward toward Europe and Russia, and North and Northeastern America as well. The moon's shadow is going to trek through Canada. It's going to trek through the western part, or I guess the northern part of Greenland and the northern part of Russia. Anyone not in that line is going to just see a partial solar eclipse. So this is the path that air quote totality takes for this particular solar eclipse, and so heading southward and northward you get less and less coverage of the sun from the moon. So people down in Africa, they are going to have no clue that this is happening because the penumbra stops right below, what is that, France, I think, or Italy. So they're not going to see it at all. These people are barely going to see a partial, and we're going to see somewhere between 20 to 60% of a partial. People, this is where the East Coast gets back at the West Coast, because the East Coast, if you go out early in the morning, this is as the sun is rising, you have the opportunity to see somewhere between 20 and 60%, depending on where you live in the northeastern part of America. But it's fleeting. It's quickly fleeting. So you gotta get out there. You gotta get out there. You gotta look at the sun. Hold on. I'm gonna explain why I said that in a second.
At the sun.
Don't look directly at the sun. Don't do it. Not without protection, which I'll talk about your protection in in just a second. But West Coasterners, you're not going to see it. You're not going to see it. That's what you get for hogging the lunar eclipse. You don't get a solar eclipse. You got to pick one or the other. You can't have both.
I just wanted to make sure to emphasize not just going out at sunrise. You should be up before sunrise. If you're on the East Coast, if you're a Yinzer and you want to see the solar eclipse, you'll want to be out before sunrise, and then pretty much as the sun rises, you'll see that it's rising while it's eclipsed.
So the sun is 100 entire Earth's diameters across. The sun is absolutely huge. And the moon is 1/4 the size of the Earth. So that's 400 moons across. But the moon is so much closer to the Earth than the sun. How close is it? Well, the moon is about 240,000 miles away from the Earth, which seems like a lot, but the sun is 93 million miles away from the Earth. So humans in general, live in the exact time where the moon in our sky, on average, is about the same size as the sun appears in our sky. And that's why eclipses happen at all. Now,
and you mean right now, because eventually the sun will get bigger, so even if
the sun will get bigger, the moon's moving further away. It's people, if humans survived all the way up until pretty much the end of the solar system, they're going to not experience eclipses like we experience them today. This is millions of years in the future, but they will not experience they will not experience eclipses in the same way that we do now. They'll still have lunar eclipses, but the moon will be a lot smaller, and they'll need more tools to see the moon better during those eclipses. But solar eclipses are gonna be crap.
If you want to know more and hear more about the sun engulfing our entire solar system, just tag into the Halloween show that I'm sure we'll be doing. We
talked about that. If you go on our site, we talked about how our solar system is going to die in our last Halloween show, When Stars Go Dark. I don't know if I'm going to be talking about that for the next one, but I have some even scarier stuff to talk about for next Halloween's When Stars Go Dark show. So come back for that.
But not in this show. This one's for families. So moving right along.
Well, I think that one's going to be for families too. The last Halloween show just wasn't ideal for families because I talked about Jack Parsons, and I'm not going to get into him on this show because this one's supposed to be for all ages. But ask your parents if you can learn about Jack Parsons, and then learn about Jack Parsons. I think he's inspirational. I think he made questionable decisions, but all in all, he was a huge driving force behind rocketry. And he did, his team, Jack Parsons' team, started JPL.
Jet Propulsion Laboratory, which is essentially a
division of
subset
NASA that
NASA.
does rockets. He was one of the fathers of rockets, but he was a wild
Reeling
guy.
you in. Back to solar eclipses.
Right. So what you're seeing right now in this image that's still up, this is a total solar eclipse. But the eclipse happening in June is not a total solar eclipse. This is just another picture of a total solar eclipse. So the moon's orbit around the Earth and the Earth's orbit around the sun are not perfect circles. So the moon can be closer to the Earth at some times, it can be farther away from the Earth at some times, the Earth can be closer to the sun at some times, and further from the sun at other times. So this is an image of an ideal situation for a solar eclipse. The moon is in this image, the moon is at its closest point to the Earth, and the sun is at its furthest point from the Earth. So this is ideal for a total solar eclipse. The eclipse that's coming on June 10th is an annular solar eclipse. Now, annular is from the Latin word annulus, meaning ring. The thing is, this solar eclipse doesn't necessarily have a totality where the moon appears to completely block the sun even though it's directly in front of the sun. And that's because for annular eclipses, at least for this image, this is an ideal annular eclipse. The moon here in this image is at its furthest point away from the Earth, and the sun, or the Earth, is at its closest point to the sun. So the moon looks its smallest in our sky, and the sun appears its largest in our sky. And this is an annular eclipse. This is similar to what people in the direct path of the moon's umbra shadow on the Earth is going to see. They're going to kind of just see a halo or a frame around the moon, and that being the sun's disk. So it's not a total solar eclipse, but at least for us in America, anyone who's not along, I mean my pointing moon, this particular path, if you're not along here, it's not going to look really any different from a partial solar eclipse when it's a total one. Meaning that, like, to us, you're not going to know the difference whether it's an annular or a total eclipse, because it's going to be partial for us, and we're just going to see some of the sun blocked by the moon, which is still great, and I still recommend it. And this is where I give my PSA about not looking directly at the sun. Contrary to what a lot of people say, it is technically safe to look at an eclipse in totality, which, again, this is not. This is annular. The danger in it is when the moon moves out of the way just enough, and you're flashed with the sun's light again as the moon moves out of the way. So it's a lot better for people to say, just don't do it. Just never do it. However, you can look at the entire eclipse safely with special glasses, and that's not normal sunglasses. There are these special eclipse glasses that were handed out like crazy whenever we had a total solar eclipse come through America a couple years ago. Some are like hydrogen alpha filtered, others just block 90% of the light, but you slap those glasses on, and no matter if you're at 1% coverage or 90% coverage, you'll be able to see where the sun is being blocked by the moon. Now, with these special glasses, before you look at the sun with them, put them on. If you can't see anything, then you can look at the moon or the sun with them, because these glasses are pretty much only the sun is strong enough to get through the amount of filtering these special glasses do. Which
don't
is why
drive with them.
Don't drive. Which is don't eat cereal with them. You'll spill it on you. Now, of course, obviously, the less coverage that you have, so the further down here you are, the less spectacular it'll be. But you know. Now, there are other ways to safely watch a solar eclipse without glasses. When I got sick on the day of that last big eclipse, I didn't go to work at the one planetarium I used to present shows at, because I was like, I'm going to be distracted by my running nose, my throat is going to get worse because I'm going to constantly be talking.
This was way before COVID.
Yeah, it was. Boy, how perspectives have changed. So I stayed home. I didn't have Eclipse sunglasses because they were at they were at my other planetarium. So what I did was I used my phone, and I don't recommend this if you value your phone's camera. And I pointed the camera up at the sun without looking at it and snapped some pictures. The camera's compensation for light, so when you point your camera at a light bulb or something, it kind of dims the amount of light that it takes in. You know, the camera did that, and so I was able to see through the camera without looking at the sun where the moon was blocking the sun. Another trick I also did was I used a colander. I held the colander close enough to the ground that I saw projections of the sun through the holes on the sidewalk, and I could see part of the projection missing. That's where the moon was. This is because of the same principle that whenever picture projection was just getting into development long ago, there were these tents that you could poke a pinhole in, and you see an upside down projection of what's outside of the tent.
We should post a video of that in the supplementary info
Yeah, I
because
could probably find a picture. I mean,
yeah, like I have never heard of that happening. I wasn't around back then.
but if you don't, if you don't want to be like me and be a sick 25-year-old holding a colander close to the ground and staring at the ground for everyone to see,
I'm normal. I'm okay.
there are other things you can do that use a similar principle. There are things, we should link this in the supplementary info too, a guide to how to do this. There are things called Eclipse boxes. And it's the same principle. You take a cardboard box, poke a pinhole in one side of the box, look at the light that comes through that pinhole on the other side of the box, and point the pinhole towards the sun, and you'll see a projection of the sun. Whether that looks less strange, having a box on your head than holding a colander to a ground, it's up to you to decide. But those are different ways to look at the eclipses, and we'll make sure to put some resources in so you guys can make them yourself, or where to find these eclipse glasses.
Yeah, not too late to order your eclipse glasses or to book a flight to wherever you need to go to see it.
So, what's happening in space when these are happening? We said that for lunar eclipses, the sun, earth, moon are aligned in that order. That's why lunar eclipses only happen during full moons. When we see a full moon, it's because our perspective, the sun is illuminating the moon straight on. So for a full moon to happen, the alignment must be sun, earth, moon. The same alignment for a lunar eclipse. So you wouldn't get a lunar eclipse during any other phase besides a full moon. Not a crescent moon, not a quarter moon, not a gibbous moon, only a full moon. Solar eclipses, again, only happen during new moons, when the sun, moon, and earth are aligned in that order. So lunar eclipses only happen during full moons, solar eclipses only happen during new moons. But the moon orbits the earth every month. So every month there's both a full moon and a new moon. So why is there not a lunar and solar eclipse every month? That's because the Earth's, or the moon's orbit around the Earth is tilted by about 5 degrees. You can see here it's not perfect. Now, I do want to say that the Earth, moon, and sun up here are inflated, just so you can more easily see it. But in our sky, as the Earth is orbiting around the sun, we see the moon's orbit rise, sink, and rise. So as we go around the sun, we started with the moon's orbit more halfway up here, and there are special places called nodes. So imagine this grid as the Earth-Sun plane, right? And then the moon's orbit is tilted about 5 degrees. So there are points where the moon is over the Earth-Sun plane and where it's under the Earth-Sun plane. It's where the orbit and the Earth-Sun plane meet that is a node. But just because the moon's orbit is in front of the sun doesn't mean we'll get a eclipse. The moon also has to be there in this orbit. So I paused it here so I could show you right here is the moon, right? So I want you to watch as the moon is going to leave the left side and it's going around the Earth. The moon orbits around the Earth in about 1 month. And as the Earth orbits the sun, the moon's orbit is going to appear to go higher, get in front of the sun, and we'll see if the moon is at that point when its orbit is in front of the sun. So it's coming up, it's in front of the sun, moon's not there. Moon doesn't get there until a little bit later. That was 1 month, that was one time of the moon going around the Earth, and so now it's back, but it missed its chance to be in front of the sun. So they don't happen every month. Even in this animation, there wasn't a solar eclipse, and I don't have it pointed behind us, but but there wasn't, in this particular simulation, there wasn't a lunar eclipse either. So they don't happen all the time. They happen roughly about every 144 days. But this simulation is only as close as I calculated it, and I calculated it pretty loosey-goosey. I made things perfect circle. I made things in this simulation perfectly, like it would be 365 days exact, 30 days exact. In real life, it's not like that. The moon's orbit changes. The moon doesn't take exactly 30 days to get around the Earth. The Earth doesn't take exactly 365 days to get around the sun. But that's the basic premise about why eclipses don't happen every month. It should be said that solar eclipses happen more often than you think they do. Like I said, the last solar eclipse that I talked about, that was years ago. And here I'm sitting here saying that, like, on average, an eclipse happens every 144 days, approximately. That's because, you know, especially for solar eclipses, they don't last long, and they don't show themselves on a lot of area on the Earth. And the Earth is mostly water. So a lot of the times, people don't notice eclipses because more often than not, eclipses end up in the ocean. The fish love it, but we don't see them as much. We don't notice them as much. And scientists, they won't really talk about one unless it's a public feature thing, like what I'm doing now.
Like one that's visible to people.
Yeah.
And also,
and then of course, people in America often aren't going to talk about solar eclipses that are happening in Europe because they don't care about that. So people in individual locations, they seem a lot more rare, but
no offense to Europe. The other thing that you have mentioned before is, like, you could get eclipses more often, but if it's just a partial eclipse, that's not quite as cool. The reason I think that these are a big deal is because to some people in our country where we are, they'll see a total, like they'll see the total lunar eclipse, because it would be possible, right, for a lot of the time, if an eclipse does happen, it's just a partial. Is that accurate?
For lunar eclipses, yeah. It's a lot less common so reasonably, if a solar eclipse happens about every 144 days, a lunar eclipse would happen about every 144 days, but not a total every 144 days. Those are less common. And then partials are more common than that, but less common than penumbral lunar eclipses. The penumbra of the Earth's penumbra is a lot bigger than its umbra, and the moon doesn't hit the umbra as much as it hits the penumbra. So most of the times, if there was a penumbral lunar eclipse during full moon, if you're walking outside, you're not going to notice it. It just dims it by 10%. If you're not looking for it, it's going to be pretty hard to notice. And then a partial penumbral eclipse, good luck. So they happen more often than you think, but they're not as ideal as the total lunar eclipse this year or the total solar eclipse for America in 2024. So just to recap, a lunar eclipse occurs when the sun, earth, moon are aligned, with the moon on the opposite side of the earth from the sun. Everyone who can see the moon at the time of totality, May 26 at 7:12 to 7:26 Eastern Daylight Time. Again, you have to convert that to your time. We have the website that does it for you on our supplementary infos page, which Becca will post again. And the solar eclipse, sun, moon, earth configuration with the moon in between the earth and the sun is happening on June 10th. Now, for us, you want to be up like when the sun comes up. And that's when you're going to see a partial somewhere in between 20 and 60, depending on how far northeast you live in the US. If you live in Canada, congratulations, go to where the path of totality is. For Canada, the darkest, the Umbra is going to sweep through Canada from 9:55 to 10:47 UTC. Greenland from 10:32 to 10:41 UTC, and Russia from 11:22 to 11:29 UTC. But that's it. That's pretty much it. The show was way longer than I thought it was going to be, but
Sorry.
more money for your buck. That is no money. Speaking of money, if you wanna help us out, you wanna support us, make us so Trevor and Rachel don't starve. You can donate to us on our website, flyscience.net/donate. All money goes directly into the production of this show. More importantly as well, though, we need word of mouth. If you like the show, tell other people about it. Share our website. Share the video whenever I put it up on the supplementary info page. The edited video that I'm going to put up is going to be slightly different than this, a lot shorter than this. So share our website, share our videos, share the knowledge that we exist, share our Facebook page, everything. But with that said, I really hope you guys enjoyed the show, and I really hope that you guys come back, watch more shows, learn more, never stop asking questions. Never be afraid to ask questions, because there's so much that we don't yet know about space and science and the world around us, and so much that we can all still learn together.
My friends would say like, "Oh, I got a B, and I'm so sad, and I feel so bad, and I'm gonna live under a bridge." And I would just, like point out that that's not true by just going, "Well, yeah, you know what they say: scientists get A's and failures get B's." And then they would say, "Hey," and I'm like, "Right,
Sorry,
exactly."
guys, I'm not a scientist anymore.
They would
I'm no longer the fly science guy. I'm
No,
the
the
fly
thing
failure
is,
guy.
it's obviously not true. And when you say that, they acknowledge that that's obviously not true.